Okay, this flow diagrams, it is actually related to movement of man and materials from one place to next place. The- ते रेकॉर्डिंग आता कोणी बदलतंय की नाही मधनं काय करतो असंच ठेवतो हा असं बघ okay now screen is visible hello okay flow diagrams this is related to man and material movements in our repair works or workshops actually movement of the man and material, it can be justified by using these diagrams. Now on the blackboards, see that the one side, left hand side, a raw material store is there. So after that, lathe, after that, shaping, drilling, milling, slotting, inspection, store is there. Okay. So materials will get flow from the raw materials. It will get processed on lathe machines. After that, it will go to shaper machines, and after that, directly it will go to the milling machines and come back to the drilling. And after drilling, slotting, inspection, and finished stock. So this is actually one of the workshop, and in that workshop, what is actually movement of man and materials this flow diagram it shows okay so here frequency will not be means how many times that material it will go come back so repetitive movement is not there the material is moving only in one direction so once the particular process of lathe machines will get over, then it will go to shaping machines, then it will go to the milling, drilling, slotting, inspection, finish. So this is the flow diagram. So when in industry, if you make these flow diagrams, through these flow diagrams, you will come to know that in which way materials and man movement is there. So main purpose of this flow diagram, we can avoid the certain movement of material and man. Okay. and because of this we can reduce the material handling cost, the efforts and efficiency. Efforts will reduce and efficiency will get increased, reduce the cost of manufacturing, then increase the production and productivity. So this is actually flow diagrams related to the work study. Very simple thing is there. Flow diagrams, it is actually related to the movement of man and materials. Flow diagrams, it is related to the movement of man and materials, and the movement of these two, it has been shown on these diagrams, and through this what actually we can do, unnecessary movement, the crossing turn. Now see that there is a cross after shapers milling, they have to go for crossing, and after drilling it will get slot. So instead of this, if you shift this milling, if you shift this milling here and the drilling will be here, sequence will be good. So this diagram, it shows this, the unnecessary or crossing movement or unnecessary movement of man and materials, we can say. This is the importance of this. The unwanted movement of materials we can do. Sometimes we need to remove the backtracking, the traffic congestions. Now here cross is there, traffic congestion is there, and we have to go for improved plant layout. Now here is the crossing. So this crossing, we can avoid congestion, we can avoid, we can make the uh, uh, this layout in such way that there should not be traffic, there should not be congestions, and unnecessary, unwanted movements we have to remove. Okay, so this is about the flow diagrams. Now, next diagrams, that is the string diagrams. So up to here it is clear. So once again, I will repeat related to flow diagram. Flow diagrams, it is the graphical representation of movement of man and materials from one place to the next place. Okay. And from this, what things you will get? The unnecessary movement we have to point out. We have to neglect change in the layout. Okay. Change in the material handling systems, unnecessary movements we have to avoid, traffic or conjunctions we have avoid. So by changing layout we can do this. Okay, so flow diagram, this is related to the movement, and the materials movement, it is in one directions. Okay, means once the from store material it will go to the lathe machine, it will not reverse back to the store, it will go to the finished stores. So here, once the materials, raw material, this is the raw material, it will process here, and here, then it will finish to the dispatch. Okay, so the raw materials are the um, man's movement. It should be in one direction, and once the material will get finished, it will go for dispatching. This is the flow diagrams. Okay, now next diagrams, that is related to string diagrams. So I will make these string diagrams in front of you, and this is a related to the repetitive motions in the diagrams. Okay. So this is the string diagrams. String diagrams means string, just like our white color string is there. So it has been used for checking the movement of the man materials. So this is only used for uh, checking the movement and its frequency. Means how many times he will go to the that machines or the inspections or to the supervisors or the toilet. The frequency it has been measured. The frequency movement it is measured by our string diagram. So here's frequency. So here string diagram is there. Instead of flow diagram, there is string diagram. String diagram. So this is our string. String diagram is there. So frequency of the movement or the materials which has been measured with the string diagram. Normally, we can make use of flow diagrams for recording the movement of man material when the movement is simple and the path is almost fixed. Where we can use flow diagram, the movement is simple, path is fixed. But when the paths are many or repetitive, so repetitive means it will go and come back. See that from tool rooms or stores, this material, it will go like this way and again come back. It will go like this, again come back. So by arrow, it can. So here's movement is repetitive. Our flow diagrams, it is used for simple and fixed path. Once again, I will repeat. Flow diagram, it is used for simple and fixed path, but string diagram, it is used for repetitive movement. In frequency, it has been counted in this string diagram. String diagram is scales plan for shops. Location of machinery, various facilities are drawn to the scale in drawing sheet. So here number of pins are located to the various location and the string over this can be wound. And this diagram normally it is used for recording complex movement of material and man, backtracking, conjunction, bottlenecks under utilized paths are easily found. It is used to check whether workstation is correctly located or not. It is used to record irregular movement. It is used to find out the most economical route. Okay, so through this diagram, what things we get, the frequency, how many times movement is made by that man or material, that will going out. Is it possible to remove that frequency? Any conjunctions, bottlenecks, any problems we can remove. Unnecessary movement we have to remove. Okay. So here's each stations we have to put the pin. So this is the pin. So here we can put pin on any cardboard. You can take one cardboard. We can put here the pin and location of the each machine, and then uh, we can just wind our string over that pin, and movement of man or materials, it shows that there is a movement of material or man from one place to the next place. So whenever repetitive things are there, we can use string diagrams, and here we're going to count the uh, man and materials movement and its frequency of measurement. Okay, so string diagrams, so normally used for repetitive motions. While constructing these diagrams, draw the layout of the shop to scale. In the drawing sheet, you can take one drawing sheet, mark the various centers like machine store and the inspection or supervisor. So you can take one sheet, you can mark the center of different machines, tool rooms, inspection, supervisor room, etc. Then you can insert their pin, and once insert that pin, you can wind our string over this, and each moment has been recorded. Okay, so this is about string diagram. So once again, I will repeat what is actually difference between flow diagram and string diagram. Flow diagrams normally used for fixed path, simple movement. Movement is simple, only one way pass is there. Previously, we have seen previous diagram. But in string diagram, repetitive motion is there of man and materials, and any problems in the productions, if it is there, any bottlenecks is there, through these string diagrams, it will come to know that there is an unnecessary movement. Okay, so frequency of movement, it shows through the string diagrams, but in our flow diagram, there is no frequency, only one path is there. But here, repetitive movement is there. When repetitive movement is there, then we can use string diagram. Okay, when a simple movement is there, we uh, can use flow diagrams for this. So this is about flow diagram and string diagrams. Then we go to the next part, that is the travel charts. Next charts, this is the travel chart. Is it clear? Very simple things. String diagram and flow diagram. Both diagram are used for uh, tracing the movement of man and material. But flow diagram, this is used for fixed path and simple path. But string diagram, it is used for repetitive movement of man and materials. So string has been used for checking or tracking the movement of man and materials. So whatever lines are given, that is actual white color string. Each station you have to locate, and a movement of the man or material, it has been traced by using the string. And if you make that string straight way, that is actually distance traveled by man and material. For example, so this from this to this, if you make a straight string, then this is actually distance. This is actually distance. From this string diagram, if you wind it, this string, if you make a straight, then it will come to know that how much the distance traveled by man or material. This also things you will get from the string diagram. Okay. Now we will go to the next travel charts. After that, template and models. After that, we will go to the micro motions, then the thermals, then CMO charts, critical examinations part is there, development and selection, like charts are there. So let us we go to the travel charts. Travel charts. Travel chart is tubular recording of presenting quantitative data like frequency of movement, weight, distance of an object like man, materials and equipments at a given period of time. So what is the travel chart? Now this travel chart, the some quantitative things has been recorded. For example, weight, distance, frequency of movement. Okay, so weight, distance, or frequency of movement, it has been recorded through the travel chart. So travel chart is tubular recording of presently quantitative data like frequency of movement, weight, distance of an object like man, material, and equipment. So this is used for weight, distance. This is used for weight, distance, and frequency of movement. Frequency of movement. Travel chart, this is used for measurement of weight, distance, and frequency of movement. Okay. So with one example, I will show this uh, how we can use the travel charts. One example, uh, workshop manufacturing three products. Example here, I will give you example. Workshop manufacturing three products. Now one workshop is there manufacturing three product A, B, C. Okay. Okay, due to light problems, we have stopped here. So, if screen is not visible, then I will send the copy of the same through your group. Okay, because the light problems, Wi-Fi problem is here. Uh, Let us we consider the one workshop manufacturing three product ABC. Six departments are there, and there is one material handling system, that is the forklift system, and each the product having carrying capacity 100, 200, and 300. So each time A will carry this capacity of forklift is carrying 100. Then this is the 200, and the C is the 300. That means with help of this forklift, the atom A will carry hundreds, B will carry 200, and C will carry 300. But total quantity need to carry, that is 9,000 numbers. Total material to be transferred, total uh, to be conveyed. Total product to be conveyed. So this is equal to 9,000. 9,000. Each product, each product, 9,000 divided by 100, 890. 9,000 divided by 400, 845. B45, and C 9,000 divided by 8. This is the atom was carrying capacity by using the forklift. Okay. So how we can make the diagrams movement to the departments and movement from the department. Okay. Movement to the department, the department. नंतर काय करू? ते दिसतच नाही का तिथे बरोबर समजा. It is visible. Hello, blackboards is visible or not? Due to light problems, not able to see. Okay. So once again, I will repeat these travel charts. This chart is normally used for measurement of weight, distance, and frequency of movement. So we have taken one example. One workshop is there. They are manufacturing three products A, B, C. Six departments are there, and here material handling system, that is done by forklift track. So A product will carry hundreds, B product will carry 200s, and C will 300s. Totally 9,000 product need to be conveyed. So each product, the conveying capacity to the forklift is A90 for A, B45, and C30. So let us, I will write here the product A90, that is the 345 and 3 product is there, three products. So how to make this uh, diagrams? So this is the diagram. I have made six departments. Movement to the departments on vertical axis, on horizontal axis, movement from departments. Okay. So try to understand this. So once again, I will repeat these traveling charts. One workshop is theirs. They are manufacturing three product ABC. A product 100, B product 200, C product 300. And this department, this workshop having six departments, and there is one forklift. With help of this forklift, total 9,000 product uh, we need to dispatch, or we need to make the movement of this. Okay. So what is the frequency or the distance or the weight, etc., related to this? We have to justify. So here's with this problem, frequency, this is very important. So because of the light problems, once again, I have faced the problem. So here's a travel chart. Three products need to carry totally now 9,000 components. We have to transfer from one place to the next place. A product 100 to B 200 and C 300. So right hand side, I have given the sequence. Product A sequence is UW, YZ, and UX. Similarly for B, UV, WZY. Similarly for C, XW, ZU, and VY. So sequence we have keep. So let us we go to the first sequence UW. So UW. So there is a U and there is a W inside. Okay. So this sequence UW. So this is the U. W here. U to W. U to W. A9. So here's U to W A9. After this, Y to Z. Y to Z. This is the Y. And this is the Z. Z. So here it is the U to X. U to X. U to X. Similarly, see that sequence it is already given. According to that sequence, just we have to locate the initially sequence for A product U to W. How many components we can carry? A we can carry 90 in UW. Then YZ 90, and after that UX A90. Similarly, you can go for B and C. B and C. So here B, U, B. So here is Q and here is the B. How much there B? B 45. Then W and X. Here is the W and here is the X. W and X B 45. Then Z1. So Z is here and Y is here. So here B 20. Similarly, you can go for C. XW, XW. So here C current, then ZU, Z and U. So Z and U is here. So here it is. Then BY. So here is a P and here is a Y. So movement from the department and movement to the department, that we are going to write. So we can count the totals here. So here's 30, horizontal 30, there it is 40, there it is 120, there is 130, there is 70, 75, and there is 90. So 30, 45, 120, 135, 75, 90. This way also you can calculate 90 180 plus 45, 225. So it is the 225, it is the 30, 45, 30, 90, 75. So, so if we see this calculation movement to the department, uh, U, V, U, W, and UX, it is more movement to the department. So this is the more. This is more. So this is the problems in this travel chart. It shows that the movement of U to the department V, W, and X is more, and how we can use this movement, it shows the travel chart. So this is the related to the travel chart. Okay, so next time we're going to see the template and models. What is the difference between template and models? After this, we will go to the micromotion study, herblings, then critical examinations. These parts will be there. Okay. So next time we are going to see the travel chart. Uh, what is that? Next time we are going to see the models and templates. So up till now, what we have seen, up till now we have seen the outline process charts that we have seen, flow process charts we have seen, 200 process chart we have seen, multiple activity charts we have seen. After that, we have gone through the flow diagram, steam diagram, and after this travel chart. So only here you have to remember when we can use travel charts, when we can use string diagrams, when we can use flow diagrams, when we can use multiple diagrams, when we can use 200 process chart, when we can use flow process chart, and when we can use outline process chart. So which charts at what place or for what purpose we can use, this only you have to remember. Okay, and at least one example. For example, this travel chart is there. Through the charts, what things you will get? The movement to the departments or movement away from the departments, how are there? So that you have to think. If you see the vertical column, the our X and W movement in horizontal position is the highest. So 135 is there. But if you see the vertical column, UV, UW, and this movement is more. So you can reduce this movement. So you have to study the present sequence, and after that you can go for modification of the sequence. So this shows the travel chart. With this, uh, we have completed today's the given task. Tomorrow we're going to see the templates and models. Okay, so we'll stop here. Certain lights, internet problems, uh, some things may happen in the sound or visibility of our blackboards, etc. That things will show in our PPT. Same PPT I will send to you. You can study it. Okay. So we'll stop here. Thank you once again to all of you. Thank you.